In this video, we're going to be looking at how to simplify index laws, and we're going to be looking at a lot of examples as well. So let's get started. How would you simplify something like this? 3 to the power of 5 times by 3 to the power of 12. This is the same thing as 3 times 3 times 3, and that times 3 12 times. So if we wanted to multiply all of these together, we can see that we're just multiplying 3 and we're doing it 17 times because we're doing it 3 times here and then 12 times over here. And we know that 5 plus 12 is 17, so this is the same thing as 3 to the power of 17. And the rule that we're using here is when you're multiplying two exponents with the same base, you add the powers together. And the way we write that rule is any base to the power of an integer times by the same base to the power of another integer. You simply add the exponents together. So let's have a look at one more example. Let's say one that looks like this. How would you simplify this? Well, we know that we're doing 6 as the base for both of these, and the indices, if we're multiplying both of them together, we just add the indices together. So this just becomes 6 to the power of 3 plus 2, or simply 6 to the power of 5. What about an example like this? Now, if we wanted to simplify this, this is the same thing as 3 times 3, 7 times. And we know we're dividing it by 3 times itself 4 times. And this simply simplifies because we know that 4 3's here cancel out with 4 3's on the top. And so we're just left with 3 times 3, 3 times, which is also 3 to the power of 3. So what I'm really doing here is I'm just minusing away the indices. So if I have 3 to the power of 7 divided by 3 to the power of 4, this just becomes 3 to the power of 7 take 4. So let's have a look at an example. Something like this. If we want to simplify something like this, we can use the first two rules that I taught you. We can first simplify the numerator by simply adding the bases because we're multiplying. There's an imaginary multiplication sign here. So this simply becomes y to the power of 17 plus 3. And that just becomes y to the power of 20. And we can divide this by y to the power of 2. And now, because we're dividing two exponents with the same base, it simply becomes y to the power of 20 take 2, or just 18. So that's how you simplify this one here. Now let's take a look at an example, something like this. Well, we can have a look here and see that if we're doing 2 to the power of 3 and that to the power of 6, all that means is you're doing 2 to the power of 3 times itself 6 times. And we know that if we're multiplying two exponents with the same base, we can just add the indices together. So this simply becomes 2 to the power of 18. But what we really did here was we just multiplied the indices together. So we can just do 3 times 6 and we get straight to 18. So let's take a look at an example. So an example of this would be something like this. So if we wanted to expand this out, we would just have to distribute the power of 3, or the cubed, to both the minus 3 as well as the a squared. So this simply becomes minus 3 cubed and times by a squared cubed. We know that minus 3 cubed is simply minus 27, because that's the same thing as minus 3 times minus 3 times minus 3. And we know minus 3 times minus 3 is simply 9, times by minus 3 is simply minus 27. And we know that a squared, if we cube a squared, then we just have to times the indices together. So that becomes a to the power of 6. Now let's have some practice. Pause the video and give this question a go. How would you simplify this indice so it's in its simplest form? Now, if we want to have a go at this question here, we need to recognize what rules we can use. We know that we're dividing x to the power of 3 by x to the power of 1, and we also know we're dividing y to the power of 5 by y squared. So what we can simply do is, when we're dividing two indices, we can minus away the bases. We can minus away the indices. So that becomes x cubed take 1 on the top, because we're just doing 3 minus 1, times by y to the power of 5 take 2, because we're just minusing away the indices again. So this will simplify to x squared y to the power of 3. Let's have a look at another example. Pause the video and give this a shot. How would you simplify this in its simplest form? So when we have a look at a question like this, which has both constants as well as indices, the first thing I would do is I would try to simplify the constants first. And the way I would do that is, I can see we have 16 and 8 over here, and these two will simply cancel, and you can factorize it out to be 2 and 1. Remember, you can only do this if there's a multiplication here. If it was addition, you cannot do that. Then I can times this 2 with the 4 here, and 2 times 4 is 8. So I have 8a to the power of 5, b times by a to the power of 4b cubed, divided by ab. Next, I can just add and subtract away the indices of certain bases. So we have a to the power of 5 times a to the power of 4, and that becomes a to the power of 9. So 8a to the power of 9. And we can see that b to the power of 1 times b cubed is simply b to the power of 4. And I can divide that by ab. And if I keep going, what we get is a to the power of 9 divided by a to the power of 1. And when we divide two indices, we take away the exponent. So it would be 9 minus 1, which is 8. And b to the power of 4 take 1, which is 3. So that's how you would simplify this indice in its simplest form. Now, another thing you should be aware of with exponents is that anything to the power of 0 is simply 1, and anything to the power of 1 is simply itself. So an example would be something like this. Even though they have different bases, because they're raised to the power of 0, the answer will always be 1. And I'll explain in another video why this is the case, but for now just know it's equal to 1. And if we wanted to do anything to the power of 1, we can see that 3 to the power of 1, 27 to the power of 1, and even minus 36 to the power of 1, those will all simply be whatever the individual bases were. So anything to the power of 1 is itself, anything to the power of 0 is 1. So let's have a look at some more challenging questions. Pause the video and attempt this question. How would you simplify this expression in its simplest form? So let's give it a go. When doing a question like this, the first step I would always do is expand out all the brackets. So when I distribute a squared into a bracket and all the terms inside here are being multiplied, you can simply distribute the squared into each term separately. And what I mean by that is this. When we distribute the squared here, that simply becomes minus 2 squared times by x squared times by y squared. And we can do the same thing for these two terms here. So that becomes times by 2 x to the power of 2 to the power of 3. That means we can multiply the indices to make it 6, and y to the power of 3. Divided by 8x cubed, y cubed. Now we know that when we take a negative number to the power of a positive indice, it'll become a positive number. So minus 2 squared is simply 4. And now we can just add and subtract our indices. We're doing x to the power of 2 times by x to the power of 6. So that'll just become x to the power of 8. And we have y to the power of 2 times y to the power of 3. And that becomes y to the power of 5. And on the bottom, we have 8x cubed, y cubed. Next, I can cancel out the constants. We know that 4 divided by 8 simplifies to a half. So I can rewrite this as 1 over 2. So a 2 on the bottom. And lastly, we can see that x to the power of 8 and x to the power of 3, they simplify to x to the power of 5 on the numerator. And y to the power of 5 and y to the power of 3 simplify to y squared on the numerator. And divide by 2 on the denominator. So this is the final answer as to how you simplify that question. Now I want to take the time to talk about negative indices for a bit. What does it mean to take something to the negative index? So 2 to the power of negative 3, for example. What does it really mean to times something by itself by negative 3 times? Well, one rule we can use here is we can simply take the reciprocal of this, so 1 over 2 to the power of negative 3, but we can get rid of the negative sign here, 2 to the power of 3. So when we reciprocate it, when we reciprocate any negative index, we can get rid of the sign, the negative sign, and it becomes the positive version. So another way of really describing what 2 to the power of negative 3 is simply saying 1 over 8. Let's have a look at another example. How would you simplify something that looks like this? So whenever we take negative indices, whenever we're working with them, we always leave it as negative until the very last step. Don't try to make it positive too quickly, otherwise it'll become a lot of hard work. So here's what I'm going to do first. I'm going to just expand this bracket out, and we know that because m and p are to the power of 1, we can just times negative 3 by 1, 2, and 1. So it's this answer. We can get m cubed n squared p to the power of minus 2 times by m to the power of minus 3, n squared to the power of minus 3, we just times the indices, so it becomes minus 6, and p to the power of minus 3. Next, I can add and subtract my indices. Because everything is times here, we can simply add the indices together. So this becomes m to the power of 3 plus minus 3, because we're adding minus 3, and that's the same thing as 3 take 3, which becomes 3 to the power of m to the power of 0. Then we can do n to the power of 2 plus minus 6, because we're adding minus 6, and adding negative 6 is the same thing as taking away 6, and that's the same thing as n to the power of minus 4. And lastly, we can do p to the power of minus 2 plus minus 3, because we're doing minus 2 added with minus 3. This is the same thing as minus 5. If we wanted to simplify this even further, we can see that m to the power of 0, I mentioned, anything to the power of 0 is simply 1. So we have a 1 at the front of this, i.e. we can simply just remove that term. And now we're left with negative indices. Whenever you simplify a index, whenever you simplify anything with negative indices, you want to leave your answer as positive indices. So if I just take the reciprocal of my answer here, I can achieve positive indices. N to the power of 4, p to the power of 5, but because it's the reciprocal, I can just do 1 divided by this. So that is my final answer. You can take a screenshot and rewatch this, but that's how negative indices work. So now I want you to give it a go at a question like this. How would you simplify this in its most simplest form? Pause the video and give it a go. Okay, so when we're trying to solve this question, the first thing I would do is I would expand all the brackets. I'd worry about simplifying the negative indices at the very last step. So let's do that first. Let's first expand these brackets. So we would have x cubed y z to the power of minus 2 times by 2, and then when we distribute the 2, what that pretty much means is we're just timesing the 3 by 2, the minus 2 by 2, and the 1 by 2. So then we can have 2x to the power of 6, y to the power of minus 4, and z to the power of 2. All over x, y, z to the power of minus 1. Now let's work through it individually. We can see that on the numerator, we're doing x cubed times x to the power of 6. So all that means is we add the indices together to get x to the power of 9. Then we're doing y to the power of 1 times y to the power of minus 4. So that's the same thing as y to the power of 1 plus minus 4, which is the same thing as 1 minus 4. And that's the same thing as y to the power of minus 3. And lastly, we're doing z to the power of minus 2 times z to the power of 2. So that's the same thing as z to the power of minus 2 plus 2, which simply becomes z to the power of 0. And we're all going to divide this by x, y, z to the power of minus 1. So when we have this now, we're dividing x's, we're dividing the y's, and we're dividing the z's. So let's do it slowly again. When we divide two indices, we're going to minus away the index. So x to the power of 9 divided by x is x to the power of 9 minus 1, which is 8. Then we can do y to the power of minus 3 take 1, which is minus 4. And we can do z to the power of 0 minus minus 1, which is simply z to the power of 1. So you notice how I've worried about the negative indice in only my very last step. I kept everything negative only until here. So now my goal is to make all the indices in my answer into positive index. So these two are okay because they have a positive indice, but to make the y into a positive 4 instead of negative 4, we just take the reciprocal of this. And that pretty much means putting the y on the denominator. So if we do the reciprocal of y to the power of 4, y to the power of negative 4, that's the same thing as 1 over y to the 4. So then if I did x to the power of 8 times by 1 over y to the 4 times by z, that's the same thing as what my final answer is here. Let's have a look at one last example. This one here. Pause the video and attempt it. Try to get this to as simple a form as you can. Okay, so when you want to simplify an index like this, don't get thrown away by how many letters there are and how few numbers there are. The principle and the method still stands as to what we did before, so let's do it how we did it before. We can see that we have a base with a here and a base with a here. So when we're dividing two exponents with the base being the same, we just minus away the indice. We just do this, minus away this. So let's do that. We're going to do a to the power of 2n take 1 minus n take 3. And I'm going to leave it like this for now, just so it helps you visualize. Then we can do times b, and we can do to the power of 3 minus the indice on the denominator. So we can do b to the power of 3 take 2 take n. Then lastly, we can do c, and same thing, we can just do the indice on the numerator minus away the indice on the denominator, because we're dividing fractions. So we have c to the power of 1 minus n minus 2 take 2n. And now all we have to do is simplify the indices in our answer. So if we wanted to simplify this, our answer simply becomes a to the power of 2n take 1 take n plus 3, because minus minus becomes positive. We know that 2n minus n is simply n, and we know that minus 1 plus 3 is simply plus 2. So in our answer, we should have n plus 2 as the indice for A. Now let's have a look at B. The indice here, if you were to expand this out, it would become 3 minus 2 plus n, because again, minus minus becomes positive, and we know that 3 take 2 is simply 1. So in our answer, we'll have 1 plus n. And lastly, with the C, we have 1 minus n take this bracket, so we're going to expand. I forgot to include a b over here. So times by c to the power of 1 minus n minus 2 plus 2n. And this simply becomes 1 minus 2, which is minus 1, and minus n plus 2n, which is plus n. And we can leave our answer like this because n is just an unknown constant. So there's no negative indices as of now. We don't need to bring anything to the denominator in this question.